In the second half of the lab, we're going to actually take our 2 grams of baking soda and we're going to take our 29 milliliters of vinegar and we're going to mix them together. But we need to take some measurements first. So the first thing we're going to measure is the weight of the beaker. So my beaker weighs 91.9 grams. Now I'm going to add my 29 milliliters of vinegar. And we're going to add a little bit of food coloring, just a couple drops. This is to make our, our lava, quote unquote lava. Obviously this, we're doing this in a laboratory setting, so this is just for fun, but don't add too much of this because obviously this is adding weight. So we are going to weigh it, but it's not reacting. So it is going to affect our numbers a little bit. But so there's my red lava. All right. And it is going to weigh 120.9 grams after. Now I'm going to add my 2 grams of baking soda, which I pre-weighed. I've got to add it slower because obviously it's going to fizz up. So now the next thing we're going to do is we need to wait for this chemical reaction to stop taking place. And the reason is, you see all those bubbles. If we look at the reaction, as a result, the baking soda and the vinegar are reacting and the bubbles are CO2, which are now bubbling out of the solution and leaving the container. So under normal circumstances, if we added up the weight of our reactants, they should add up to be the same weight of our products. But in this case, since one of our products, CO2, is bubbling away and leaving the reaction, we are going to lose some weight. It's that weight that the lab is about. We're going to actually see if the amount of weight that we lost from CO2, how it compares to the amount that we could calculate. But what I'm going to have to do now is I just need to keep stirring this because I want to make sure the reaction completely finishes. And even then, the reaction's probably not completely finished. I probably should let it sit for a while, maybe even overnight potentially to let it really finish. But the reaction's probably 99% done, which is good enough for what we need. I don't see any more bubbles forming. I mean, only the bubbles from the actual stirring. But other than that, I don't see anything. All right. And the new weight is going to be 121.9 grams. All right. Now, we made a mistake. This is going to be the beaker plus the products, 121.9 grams. So my total mass of my reactants is going to be the weight of the vinegar, which was, if I subtract out the beaker, let me get a calculator. So if I take my it should be 122.9 because I'm going to add 120 plus the 2 grams of baking soda. And I'm going to subtract 91.9, which is the weight of my dry beaker. And I got 31 grams of reactant. So hopefully everyone followed along. I added these two together. So I added my vinegar plus food coloring and my baking soda. In other words, this was vinegar, food coloring, plus the beaker, and then I just subtracted. So I added these together and subtracted the weight of my beaker, and I got 31 grams. Now, if this works perfectly, you should get 31 grams of product, but we know that the CO2 bubbled away. So now let's see what we get. 121.9 minus 91.9, which was the beaker. I got 30 grams of product. So what this is telling me is that 1 gram is missing. that 1 gram is going to be the weight of the CO2 that bubbled away. So post-lab questions, determine the total mass of the reactants only. I already did that. 31 grams. Total mass of the products only, 30 grams. We did it right here. Determine the difference between the mass of the reactants and the mass of the products. 1 gram. We did that already as well. How many moles does this represent? So what you're going to do, this is 1 gram of CO2. You're going to use the mole formula. And calculate how many moles that would be. Now, that is going to be, just need a red pen. The answer to this is going to be your measured, actually no, the original answer, right there, 1 gram, is going to be your measured number of grams of CO2. So this is how many CO2 grams that we lost. That's easy. The next one, we're going to figure out how many grams of CO2 should we have. All right, so this part I'm not going to do for you, but here's the way it works. So it says, using the mole-mole ratio, calculate the number of moles of CO2 that should have been produced. So the way we do that is simple. We're going to do a mole-mole ratio from baking soda to CO2. The number of moles of baking soda is going to be our answer to number 2. So this is going to be the answer to number 2 on the front. It's going to go right here. And then you're going to do a mole-mole ratio and get your answer here. This is going to give you moles of CO2. Once you take your answer, you're going to plug it into the mole equation, and you're going to solve for grams of CO2. This answer right here is going to be the accepted value for the grams of CO2. So now we have our measured value, 1 gram. We have our accepted value. It's going to be something close to 1 gram. I'm not going to tell you what it is. I want you to calculate it. And then you're going to do a percent error where you calculate the measured minus the accepted over the accepted for this lab.